So a few words about our speaker. He is distinguished research professor, actually professor emeritus at the School of Social Science.
Not professor emeritus.
No, you are a distinguished research professor. You in other respects, you are an emeritus, but not with this position.
Good. I'm not an emeritus.
Yeah, basically, you just don't stop, basically.
Correct.
Yeah, okay. So at the School of Social Sciences at Cardiff University in Wales, in the UK. His previous stations include, among, I think, various guest professorships, the University of Essex, that's where it all started, and the University of Bath. I will come back to that in a second, because Harry is one of the initiators of the strong program in the sociology of scientific knowledge. That was what happened in the 1970s. And there were basically two schools at that time in Great Britain, and that was like the leading part of the world in the social studies of science at that time. And there was the Edinburgh School far up north, and far in the southwest, there was the Bath School, and Harry is one of its initiators. Here's a few achievements, awards. He was president of the Society for the Social Studies of Science between 1991 and 1993. He won the Robert K. Merton Book Prize for his book, The Golem, in 1995. He was awarded with a J.D. Bernal Award for the contribution to the social studies of science in 1997. And he is an elected fellow of the British Academy since 2012. And that's just like a few snippets, a few highlights from, of Harry's career. So, and then I wondered how to introduce Harry's accomplishments content-wise, and just instead of just saying what prizes he won. And so I thought I might start with a short quote, shortish quote from an interview that's, I think, 8 years old now. And this is how it all started. And I think it's, in a nutshell, it encompasses at least part of the essence of what Harry's work is all about. So, with Ideas quote from Kuhn and Wittgenstein, I thought I would study the ability to learn to build a TEA or T-laser. What I discovered was that the only people who succeeded in building the laser and making it work were people who had social contact with other people who had a machine that worked. That means going to their lab, basically. That was my discovery, and I wrote this up and said, well, this shows that learning to build a T-laser is like learning a language, not like learning discrete pieces of information, because you can only learn it through social contact in the way you learn a language. The title of the thesis was The Sociology of the CO2 Laser. End quote. There follow a few sentences about the reactions of his audience at that time, which was a kind of amusement and astonishment at that time. That was the early 1970s. And Harry did quite a lot to overcome this kind of reaction back then, that was quite familiar back then. Namely, there can be a sociology of scientific apparatus, of scientific experiments, of scientific controversies, most of all. So, and what Harry engaged in and developed was a microsociological approach to scientific knowledge, in the framework of the social construction of science and technology. So, some keywords here: there was interpretative flexibility, scientific controversy. So that was one of the main fields of Harry's interest. Interactional expertise that has to do with the social contact, referred to in the quotation. The social model of knowledge, which was also contained in that short quote, and the notions of tacit versus explicit knowledge. And the main empirical fields that Harry is dealing with are gravitational waves, like that's like the big time field that Harry has been engaged in for 45 years now, artificial intelligence, which we'll hear about now, and perhaps interestingly, parapsychology. And how this all hangs together will be one thing for us to be explained by our speaker today. So without any further ado, I will stop my screen and Harry will start his. Floor is yours, Harry. Welcome.
Okay, thank you very much. Let me see if I can get my screen to share. You can all see it? Yeah. Okay. So I wanted, first of all, I'm going to explain something about the style of the talk I'm going to give. And I'm going to start off by telling you a joke. Why does the English actor Edward Woodward have 4 Ds in his name? Well, I can't hear any replies, so I'll tell you the answer. Because otherwise he'd be called You-Wah Woo-Wah. And I can't hear any laughter. Here's one of the troubles with Zoom instead of being in front of the audience. If I was in Munich now, actually talking to people live, you'll all be laughing and laughing and laughing. But because you're not laughing, it's not like giving a normal talk. So for that reason, I'm going to try and keep my presentation short. I don't know if this will work out because presentations, you don't always know how presentations are going to go. But my intention is to keep it short and give more time to the question session so that we can have some life from the audience as well as just me droning on. That's the idea anyway. So let me start with the presentation. The first question is, what is artificial intelligence? There are 3 things it might be. There's probably more things, but there are at least 3 things it could be. A set of programming ideas and languages for building a set of useful tools. And a lot of people who describe themselves as working in AI say that's all they're trying to do. They're not trying to do anything grand. It's nothing metaphysical. They're just using different programming languages to help automate things a little bit better. That's not what I'm talking about. Secondly, AI can be a replacement for humans in various roles, such as the workplace or in the driver's seat. And thirdly, the thing that I'm really interested in is AI as a science which attempts to understand humans by mimicking or reproducing or improving on their abilities. What you're trying to do is, you know, like if you want to understand something physical, you try and build a copy of it to see if you've understood it. And the same, I think, applies to human intelligence. We're trying to build a copy of human intelligence to understand what human intelligence is. Now, this third thing, which is the thing I'm most interested in, also has some implications for number 2, a replacement for humans in various roles. Because as you're trying to understand human intelligence, you're beginning to realize, you're working out what it is that you need to do to replace a human in various roles. And you begin to understand all the things that go wrong with artificial intelligence because, you know, you haven't understood the human properly. So it's 3 that this is mostly going to be about. Now, what is a human? Well, AI, the science of artificial intelligence, has already told us quite a lot about what humans are. But so far, it's told us this not from succeeding, though I'm going to say there is one little success that's interesting, but mostly from failing. It's failed at various things. It's succeeded in some things, but failed at others. So one of the most important things we've learned from trying to mimic human intelligence is we've discovered that the high point of human intelligence is not arithmetic or mathematical ability or chess, because all of these things can be done pretty easily by a machine. It took a while to get to produce chess championships or Go champions, but it turns out you can do it, and we understand how to do it. So it's not this mathematical stuff or logical stuff or stuff like that, but the difficult things to reproduce are the things that everybody can do, or nearly everybody can do, such as fluent native language speaking, you know. And I'll give you some examples of how AI fails in that. And on the way to discover that it's extremely difficult to mimic fluent human language speaking, we've discovered, in case we didn't already know it, but I mean, sociologists already knew it, and other people already knew it, but we've discovered, and you know, AI is really showing us that it is the case that human intelligence is social, not individual, and that it is acquired through embedding in human social groups. And just something we already did know, that feral children who are captured by wolves or other kinds of animals and brought up in forests, don't develop normal human intelligence. They don't develop language. They don't develop normal human intelligence. And as far as we can see, if they don't develop this early on in their lives, they don't develop it at all. They don't develop the ability to learn human language later. You have to have got this ability to speak fluently at quite a young age in order to have that difficult bit of human intelligence. So there's a place where it's obvious that human intelligence is developed collectively. Now, deep learning, and this is one of the reasons why deep learning, the latest success in artificial intelligence, and it is a success, you know, it's the most successful way of doing artificial intelligence we've ever had, that deep learning is hugely more successful at language handling than previous AI projects, because it teaches itself and can draw on society's written language as it occurs and changes on the internet. You know, however good a language program you build for a computer, it still won't change in the way human language changes unless somehow or other it's in touch with all those changes. You know, think about your teenage kids if you've got them. They're using language in a way that you never use language. So the language is always changing and no one's in control of that. It's the society that's changing language and nobody can predict it. You can try and change it. I mean, certain authors have written books in which they invent new languages, but they're not in a position to say whether these new languages will be picked up and used or not. It's society that decides that. However, even AI is not a complete success because it doesn't inhabit society very well. Just ask yourself, if you were bringing up a child, would you be happy for it to learn language by picking up written language on the internet? No, you know that wouldn't be good enough. The child has to be much more deeply immersed in day-to-day life. And it's ever so easy to demonstrate where language learning fails in respect of this. Lots of little easy demonstrations. And here's one. I did this the other day, about 3 or 4 days ago. I typed into Google Translate, and Google Translate is a terrific language translation program, uses all the deep learning, it's learned from all the deep learning it's got, and it's very, very good in that respect. And I typed in the thing on the left, not my idea, by the way, to type in this. It's a man called Terry Winograd, who invented things called Winograd schemas. And Terry Winograd, this is an example of a Winograd schema. It's one of Terry Winograd's. The trophy would not fit into the suitcase because it was too small. Now, I asked Google Translate to translate it into French. So there's the French translation on the right, but with a word missing. And for anybody who's good at English and French, perhaps you could think about that French translation on the right and tell me what the word should be that's in the little circle there, the blank circle. It's the word for it. But what should the word be? So you see how good it would be to have an audience, because everybody could be putting up their hands and saying what they think. But you're not doing that. You're not able to do that. So I'm just going to assume that everybody's had a go. And now we'll have a look at what Google Translate came up with. Eel. And I hope that everybody's saying, no, that's wrong. It should be L, because suitcase is feminine in French and it's the suitcase that's too small, not the trophy. But in order to get that translation right, you have to have really inhabited the society for long enough to know the world of trophies and suitcases. Now, of course, it would be a trivial thing to fix that particular example now that it's been pointed out. And there did seem to be a time when it had been fixed on Google Translate. Somebody told me it had been fixed, but when I checked it the other day, it hadn't. But the point is not to fix single examples by looking back at them and applying little tricks. The point is to fix the general problem, which is immersion into the society. And if you want to build an intelligent machine, I'm arguing, you've got to build one that can be as deeply immersed in the society as a human baby is. If you want to read more about this, this is my book, published in 2018, Artificial Intelligence. And chapter 10 has lots of discussion of these kinds of examples. And you can decide whether you agree with them or not, or you can start thinking about how artificial intelligence might fix them. But it's ever so simple little thing, ever such simple little things like this that you can do it, because as I said, the difficult thing for artificial intelligence is the things that we can all do, like speak fluently. As we know, if you want to become fluent in the language, you must visit the society and immerse yourself in the discourse. And the same applies to the other things that I call ubiquitous expertises that define a culture. How close should you walk to somebody on a pavement, depending on whether it's crowded or whether it's not crowded? If there are very few people on the pavement, you better keep a distance from anybody else who's walking towards you. Otherwise, they'll think you're doing something funny. If there are lots of people on the pavement, then you can get close to the other people. But those are the sorts of things that vary from society to society and social group to social group. And the only way to learn them, as far as I can see, is to be immersed within the society, because to attempt to describe them in a formal way, there's just too much description to do. Now, the whole flavor of the talk is going to change now, because now I'm going to something far more general and far more political. And I'm going to say that one of the things that artificial intelligence is showing us is that the individual model of the human is simply wrong. This is what I call the fractal model of society. Now, if you look at that top oval up there, you'll see the sorts of things that everybody already knows in a particular society, and the sorts of things that define a society. So fluency in the natural language spoken in that society is one thing. Knowing how to walk on a pavement is another thing. Ethics, you've got to understand what counts as ethical behavior in that society. Otherwise, you won't know you won't know how to avoid being locked up. So everybody has to understand ethics. Everybody has to be an expert on ethics if they want to avoid the police. And as I'm going to say later, it's very important to understand, if you live in a democracy, what a democracy is. Otherwise, the democracy won't survive. Now, within this large oval, there are lots of other subgroups embedded in a very complex overlapping way. To draw this properly, you'd have to have a multi-dimensional diagram, but I've only got two dimensions. So we'll have this multi-dimensional diagram will have to be represented on the page in this kind of way. So you've got people who are parents, people who are commuters, people who are mortgagors that have their own mortgages. And all these little groups require different sets of societal skills. There are Christians I've put here. There are scientists here. There's the law. There are fortune tellers. There are bird spotters. There are cricketers. There are farm workers. Well, you can see how it goes. You know, you can. add as many of these things as you like, and I've just got a few of them there. But that's what a society is. And what a human being is a collection of those sets of social skills. Societies, and this is the political thing I'm getting into, societies are not made up of individuals, but they're made up of domains of expertise. Individuals are combinations of a subset of such expertises as are made available in their society, a subset of those expertises in which they've been immersed, and that is personhood. So this is a picture of you. Now, God, I wish there was an audience, because I'd expect a laugh now, see, then I'd feel encouraged to go on. Anyway, I'll press ahead. So it depends where those arms and legs and head actually goes in the society. That tells you what sort of person you are. Now, the implications for deep learning, let me go back. The implications of what I said earlier of this model for even AI that's as good as deep learning AI is. This is a model drawn by, this is a model that belongs to Ray Kurzweil, the director of engineering at Google, I hope that's right still, of the human brain. And he says the human brain is a hierarchical pattern recognizer. So it looks like that. Those are all neurons. There's a high level at the top. Can we draw it? No, we can't get the pointer onto it. The high level, information comes in at the bottom. It gets filtered by level after level after level to see if it looks reasonable. At the very top are memories, which say, well, you've decided as you've gone through all this, that this image that you've just seen could be one of these. I've got one of these in my memory, so I'm going to give it a tick. Or I haven't got one of these in my memories, so I'm not going to reinforce the synapses that gave us this image. And so it goes. The brain is learning to recognize things and learning to reject things. And that's how we come to see what we see. Now, I actually, as a sociologist, think that's a pretty good model of the brain. I don't know if it's right. Any neuroscientist will tell you it's wrong and the brain is much more complicated than that. But in sort of essence, in concept, it seems like a pretty good model of the brain to me. However, it's not quite right. It's got a bit missing. And so this is in my book, incidentally. It's from chapter 7 of my book. So I redrew it like this. What it's missing, of course, is an even higher level of synapses. And that higher level of synapses are the synapses in everybody else's brains. And there's a big higher veto level, for instance, teaching you to speak English, vetoing your child's utterances when they're garbled and don't sound like English or German or whatever language they're learning, and reinforcing it when it does sound like English, German, or whatever. So really, the brain is immersed in lots and lots of other synapses, which belong to all the other people in the society that the human is in contact with. That's just a diagrammatic way of saying what I've already said about human intelligence being essentially social. Now let's get on to the more political aspects of it. Political implications of the fractal model. There you are, with consisting of a set of socially acquired skills, abilities, and understandings. And what that means is there is no pure freedom of choice. The pure freedom of choice loved by those who think that democracy is just everybody choosing what they want. Human abilities and choices are enabled and formed by societies and groups. You don't think so? Okay, speak me a few sentences in Chinese or Japanese or some other language that you can't speak. Are you free to do it right now? No, you're not. So you can't be free. And you're not free in respect of most of the choices you make. It's basic sociology. The answer to this, I mean, sorry, we've missed a bit somehow or other. In that top right-hand corner there is understanding democracy. Remember, I mentioned it earlier. And one of the things you need to understand if you want to understand democracy and know how to vote at the next election is you've got to understand that society looks like this, not like a set of perfectly free individuals. And you've got to understand how all these ovals relate to each other. What's their hierarchy? For instance, you will have discovered, if you lived in Britain at the time of the Brexit campaign, incidentally, I should say, I think it was a total disaster, if you're wondering, that you thought the law was an important institution, an important group, because the law could stop Boris Johnson doing exactly what he wanted to do. It stood in the way of Boris Johnson. And you will know that there are other, what democratic theorists call checks and balances. There's in the British Parliament a loyal opposition. There's other chambers like the House of Lords in the UK. There's the press, which is a noteworthy check and balance. And one of the things I'm arguing, and this is important for this talk in particular, is that scientists, the scientific community, is a check and balance on what communities can do. And I think you'll have noticed this in the recent COVID epidemic. I think we were really, really lucky that COVID came along. Now, that may sound an odd thing to say, but, you know, COVID is killing quite a few million people, but not as many as were killed in the Second World War. And the last time there was a serious threat of fascism of the kind that it looked like Donald Trump was going to impose on the world was in the Second World War. And luckily, Donald Trump decided to oppose the scientists and scientific experts in respect of COVID. And I'm pretty sure that's why he didn't get re-elected for a second term. So we're very, very lucky that we've got scientists as a check and balance. And in this case, they acted as a check and balance on Donald Trump and stopped him being elected for a second term. And let's hope they stop him being elected again, because I think if Donald Trump gets elected, we're all in very serious trouble. Now, to get people to understand this, they need to understand democracy. And I don't know how we get them to do that, but I think the only thing I can think of is more civic education, more understanding of how societies work, more understanding of the nature of democracy, and more understanding of the role of experts within the fractal model, so that next time they'll again not vote for people who are prepared to roll over the normal checks and balances of a pluralist democracy. That's what I've just said, but I'll read it again. It includes an understanding of the role of experts as a check and balance on the power of those who would be dictators. Expertise is not in conflict with democracy. It is a foundation of democracy. Two models of democracy here. There's what I call popular assertive democracy, every individual asserting their right to vote as they like. And that's structurally constrained democracy, which is how it really is. And here, people who want to act purely on what they call the will of the people are held in check by checks and balances, and that allows for the continuation of a pluralist democracy. You want to understand the role of the internet? Well, think of figure A there, that little A there. That's one of those ovals in the fractal model. And B is one of those ovals in this incidentally is the kind of oval I watched. I spent 45 years studying scientists trying to detect gravitational waves. and eventually detected them in 2015. And what those scientists did was work in small closed groups where they learned to trust each other. They threw a lot of people out who they didn't trust or didn't think were doing very well, but it was a kind of formation of expertise, just like learning to speak a language. Here in B, you've had such a group invaded by internet connections, social media, etc., from a distance, often that distance being from unknown places, sometimes it being organized by states who want to sow disinformation in the society. So that A turns into something that looks a bit like C, which means the fractal model of the society D turns into something like E, okay, something much more amorphous without those groups of experts. And that's very, very dangerous. So structural constrained democracy, which is what we need, is replaced by aggressive individualistic concentrations of economic and political power, such as these. That's a very, I like that diagram. It's a very easy way to understand the dangers of conspiracy theories, of the internet, of the uncontrolled internet and so forth. It's actually going to make structurally constrained democracy impossible. So let me sum the whole thing up. The huge importance of AI. It's a science which attempts to understand humans by mimicking, reproducing, and improving on their abilities. And it's a very, very important and salient science. First of all, it's one of the wealthiest sciences of the world, or possibly the wealthiest science. The money that pours into AI is huge. It's run nowadays by people like Google and so forth, who get money from private enterprise. And I wish it would act more like a science, because we desperately need science if we're going to have a democratic society. We need science to be a check and balance, and we need science to be an object lesson for how to make very, very difficult decisions. We need, and the great thing about science, and good science, is that the people engaging in the science are trying to find the truth of the matter. And if you want decision makers, they may not be right, but at least find people who are trying to find the truth of the matter. The trouble with AI is it tends to be too slick in presenting itself. It's always saying it's solved the Turing test and taught computers to speak fluently when it hasn't. And really, it should be the AI scientists themselves who are investigating their own abilities and telling everybody else that they haven't yet done it. This is what they do in gravitational wave detection. They make sure they do everything they can to make sure they never announce anything until their own team has put every effort into trying to prove themselves wrong. But AI is also important because it can reveal that humans are essentially not individuals, but members of collectivities. To do this properly, it should act more like, that's what I've just said, more like a science than a bag of tricks, and should be more self-critical. And that B, in that role, its importance turns out to be political as much as psychological and philosophical. Thank you.
Thank you very much, Harry. Please, can you unshare the screen? Then
Sure, yeah.
So, and I saw many people laughing. No, I didn't saw them, but many people were laughing, and some wrote in the chat. So there are some disadvantages of Zoom, but there are also advantages because we had 114 participants, and in Munich we couldn't have so many people in our room. So we have to decide. Okay. You're unmuted, Hayo. You are muted.
Yes, and also thank Harry. And we're now floors open for discussion. And we shared our duties, Rudi and I, that he will take care of the people who raise their hands, use the raised hand function. There's 2 people of this kind right now, as far as I see. And I'm going to look at the Q&A chat. Okay, so far there's 2 raised hands, 3. So Rudi, you happy to manage them. And Cynthia will, if the people wish to, will allow them for a few minutes to be visible. Mm-hmm.
Yeah, I think the first is
Hi, Christian.
Yeah. So you can unmute Christian Wenzel, and then you can give your, yeah.
Okay. Can you hear me?
Yes.
Okay, thank you, Harry, for the talk to the point, short, gives us much time. I'm German, living in Taiwan. I speak Chinese, but I find it very difficult to make jokes. And this is related to your first example with the il and l. When I read it in English first, I thought it was a joke. So I thought it was meant as a joke. So I understood.
Wait, so sorry, just say that again. Which is it you thought was a joke?
So when I read the English example with the suitcase, and I read the it, not referring to the suitcase, but to the thing you put into the suitcase, and I thought it's a joke. I don't know why I got onto that track, and that's why I thought it should be il and not l. But then I thought, well, a joke is something very complicated. And the example of AI is that the AI needs to understand the context to get the il and the l correctly. But a joke is a much more complicated context. And it's a social context because you're telling a joke to somebody who doesn't know it yet, otherwise it wouldn't work. So can you say something about AI and jokes? I mean, the social requirement for a joke.
Yeah, I mean, obviously a joke is a very difficult example of how to be fluent in a language. As a sociologist, one of the criteria I use for whether I've understood a new scientific group is whether I understand their jokes. And better still, whether I can make some jokes which they'll laugh at. But this is very hard because it's, you know, what one is trying to do, what I'm trying to do here is produce very simple tests for AIs. And since we don't know whether an AI is laughing or not in a Turing test, because all we have is print on a computer screen, these little, very, very simple tests are in a sense better. We want to make it as easy for the AI as possible. And then if it still fails, then you know you've really got something. We don't even need to get to the really hard thing, like having the AI understand, you know, resolve jokes. That's really difficult. You can check it. I mean, where I start, the first example I give in my book is of a spell checker. So I write in my book, I am going to misspell a word, you know, and then I do actually misspell the word. Okay. And the spell checker underlines it. But the human editor of the book knows that it shouldn't be underlined, knows that it's spelled exactly as I intended it. So that's an even simpler example. Yeah. So yes, you're right about jokes, but jokes is in a sense too difficult an example. We'll get to jokes eventually, but some way down the road.
Okay.
Okay, thank you. I think, Hayo, you have one in the question and answers.
Muted, you're muted, Hayo.
Of course, sorry, I've been muted. Here's an anonymous attendee, so which means I can't make that person heard. So I can only read the question because if you're anonymous, I can pick you from the list and allow you to speak. And he or she is asking, how would you define immersing oneself into a society? What is necessary to be immersed? what must an individual do in order to do it successfully?
Oh, okay, that's a pretty good question. And it is going to depend on how hard it is to acquire the culture of the society. Now, the first thing is that anthropologists who go overseas to study tribes who live in jungles have a very difficult time of it because they have to learn the whole native language to start off with. Me, who wanted to learn the language of gravitational wave detection, had an easier time of it because fortunately most people in the scientific community already speak English fairly well. So I didn't have to learn English. And they're largely English speakers. So I didn't have to learn English in order to get to the point when I could start learning the language of gravitational wave detection. And so I could learn the language of gravitational wave detection as most ethnographers do, that's as opposed to anthropologists, as most ethnographers or sociologists do, by spending a few months a year at the conferences of the scientists I wanted to understand, at their conferences, and by going around and interviewing them. Now, an important thing is this, that in order to understand the language of gravitational wave detection, I did not have to be an active participant. I didn't have to be publishing papers. I didn't have to be doing calculations. I only had to be immersed in the spoken discourse of the gravitational wave physicists for long enough. And then to find out if this was true, we arranged a test where I pretended I was anonymized. We did a Turing test, but with humans. I was anonymized. There was another gravitational wave physicist who was anonymized. And then there was a third gravitational wave physicist who was asking questions about gravitational wave physics. Okay. So the third gravitational wave physicist asked, he actually, it was his choice, but he decided to ask 7 questions, one after the other. And we two, who were taking part in the Turing test, had to answer. And then they gave the answers to 9 other gravitational wave physicists. And the 9 other gravitational wave physicists said, well, here's the set of questions down the middle, and here's the 2 sets of answers. Which one of these is Harry Collins? They all knew me. And which one of these is a gravitational wave physicist? And the way it worked out is that 2 said I was the gravitational wave physicist, and the other 7 said they couldn't understand. They couldn't work out which one was which. So I passed as a gravitational wave physicist in a Turing test. And I repeated that experiment some years later and did pretty well again. So that's what's meant by immersion for me. And that's how you do it. Does that answer the question, or does your questioner want to have a follow-up? This is the problem with not being on screen, because I suspect they might want to follow up.
I'm not sure whether what's written here is a follow-up, because it's, again, anonymous attendee. And it might be a follow-up. It might be somebody else. We don't know. So it's, again, a Turing test. Okay, and the question is, as society is an important aspect of human behavior, what roles for social and psychological studies do you see in the future development of AI?
For social psychological studies?
Social and psychological.
Oh, social and psychological studies.
Social and psychological.
Well, it seems to me that the role of social studies anyway is to do what I've been doing, is to show what it means to be a human, so that AI practitioners can set themselves difficult tests for their own science. At the moment, I don't think they've been setting themselves difficult enough tests. You can read over and over and over again that some new machine has passed the Turing test. And it's pretty obvious that nobody's really tested it very hard at all. And they obviously then don't know what it is to pass the Turing test in a meaningful way. So a sociologist like me can explain what it is to pass the Turing test in a meaningful way. I mean, there are some AI scientists who do it, but very few.
Okay, I think.
Okay. Wait a second. Because here I think this is a real follow-up, because it starts with but. It's again anonymous entity. One of them, I move this one forward because it reacts to your last remarks. But could this kind of immersion question answering in the style of an expert, like this gravitational wave Turing test, not also be achieved via a simulation, as the Chinese room experiment by Searle shows? This would only be a simulated immersion, but nevertheless pass the Turing test.
Yeah, this whole area is just so crap. Me saying so. The Chinese room experiment does not show that a machine can pass a test like this or pass the Turing test. The Chinese room hypothesizes that a machine has passed the Turing test and then points out that there's two ways to do it. One by being conscious and a fluent speaker, and one by not being conscious. But that's a hypothesis. It's not a proof. We do not have a machine or anything else that can sit in the Chinese room. Now, Searle has a model of it happening by looking up a kind of dictionary with all, there's a better guy called Ned Block who has a dictionary of all possible human conversations that there have ever been. The mere fact that it's, you know, 1 billion times bigger than the universe, or almost an infinite number of times bigger than the universe, isn't taken into consideration. But even if we don't take that into consideration, it won't work because language is changing. So that even if you could invent some fantastical machine like this at time t, where it was perfect, the Chinese room, at time t+1, it wouldn't be perfect any longer. It has to be immersed in the changing language, as humans are, in order to keep up with language. So be careful with the Chinese room. It's nearly always misinterpreted. It could have, the same point that Searle wanted to make, that you can get some responses either through consciousness or unconsciousness, could have been explained far more simply and with a pigeon in the room, just pecking at results. You just ask simple questions.
Okay, the next question comes from the chat, and it is Linda Janssen. And Cynthia, maybe you can give her permission to be seen in the screen and to allow her to speak.
Yeah, wait a second.
I think Linda Janssen, and now it's Lina Kluy. Maybe it's a different person. Yeah.
Oh.
Okay, you are still muted, but yeah, okay.
Okay. Thank you. Hi, Harry. I'm a student, a doctoral student in science and technology studies at Virginia Tech. Okay. I've heard you speak before, and I was really looking forward to this. Thank you. So I'm studying what we call data science, which is sometimes used synonymously with artificial intelligence. And it seems, and I'm looking at those claims that you mentioned, the claims of success. That this works and this is, we're able to replicate human intelligence. But it seems to me that the incentive structure, because much of the research in AI seems to be coming from military applications as well as industry applications. And so these claims of unmitigated success are incentivized. They're rewarded with more money and more research, and it's a never-ending cycle. And I just wonder, how do you break out of that to get out of that bag of tricks syndrome that you mentioned and more like a real science? It doesn't, I don't see a way forward, but would like your thoughts on that. Thank you.
No, I agree. I don't know is the answer, how you break out of it. The only thing I know how to do is try and shame people out of it by giving talks like the talk I've just given. You know, don't you want to be a member of the honest scientific community? That's all I can think of saying. You know, the question is whether you want to be rich or whether you want to find the truth. I'd say that people who want to be primarily rich should go into banking rather than science. It's a much more secure profession. And maybe we'll be left with the honest ones who really want to pass the Turing test. It's a fascinating project, passing the Turing test, making a machine that can mimic a human properly. Why would they want to pretend to be doing it? But I've always had a puzzle why people would cheat in science. I've never understood it. It always seemed to me that science is such a fascinating and exciting thing. There's no point in cheating. What you want to do is have scientific success. So that's not a very satisfactory answer. It's not the best
I would just say shaming is difficult when the origins of these algorithms is often obscured. And so you don't have this ownership like you do with other scientific papers or theories or things that get published. So that just complicates it. That's your social media environment that you were talking about. It's often anonymized.
Yeah, I mean, I have some experience of this, not in AI so much, but in, people might know about this, in what in Britain is called VAR, which stands for Video Assistant Referee. If you're football followers or cricket followers, well, you guys in Germany might be football followers. In America, you might be, well, you've got VAR for baseball, but I don't know, it might work better there. But in Britain, the thing is disastrous. You have VAR used for judging making the offside decision in soccer, football, to within a millimeter. Whereas if you work it out, you can tell that the error bars are up to 8 inches. But nobody talks about the error bars. So there's something that is really bad science being presented to the public there. And it's not a secret. You can find in the newspapers them saying that so-and-so was offside by a millimeter with, this was in the early days, but with a huge error bar. And then everybody just forgets about it and goes on. It's very, very weird. And that I can only assume it's because people are making a lot of money out of it.
Thank you.
Okay, so we have another anonymous attendee writing in the Q&A chat. And I think some people even wrote into the normal chat. So we have to take care of this as well. But let's first go for the anonymous attendee I have here. And he or she says, well, it's a bit of a crystal ball question. I'm a linguist and I'm interested in language and AI. In your opinion, how can machines ever learn the full social context of natural conversation?
Well, as I said, I'm perfectly prepared to accept Ray Kurzweil's model of the human brain and how learning goes, except that it should have this extra bit on top, this extra layer. So what you have to do is build a machine that can be brought up like they attempted to bring up Washoe the chimp, who they tried to teach language to, you know, with as much human contact as a human child growing up. And if the machine could then learn all the language that was happening all around it, I think it would have a very decent chance if Kurzweil's model of the brain is right. You know, I'm not likely to provide new kinds of technical algorithms. I can't write an algorithm for a better AI. but I can say what the algorithm has to achieve, which is to enable the machine to learn language in the same way that a child learns language.
Okay, the next question in the chat is by Harry Potts. So can you have the permission to speak and to be seen? Oh, he left the webinar already. So he gave you a question. You want to hear the question, but he's not here anymore.
I don't know. It depends whether you have a queue of questions or not.
Yeah. Okay, then let's go to the other questions.
You have two raised hands by Andre Ilcic and Silja Wang. I think we should pick up Andre at this point, perhaps.
Okay, thanks. I think you can hear me. Thanks, Harry, for the talk. I had a couple of questions, but I'm going to go with this one since it's a bit related with what you just said. I was thinking about your argument with based on the Turing test. And Turing also had this idea, it was a couple of years before he proposed the Turing test. And he said, well, if we're going to have an intelligent machine, we should actually treat it as a child. We should give it the brain of something like akin to a child's brain, and then send it to school, have it play with children, and so on. And then so he was basically proposing some form of machine learning based on neural networks at the time. So my question is whether that kind of experience could also be simulated. I mean, I guess it would involve having a model of what goes on in a society, and then use that model in a computer to simulate the whole environment, and then we could use that to raise, in a sense, this machine. But I see a point in that a direct one-to-one map with Ray Kurzweil's model of the brain, which you had just upgraded. I was wondering if you shared that intuition. And I also wanted to ask a question about free will. I was wondering if you believe in free will. You mentioned that it's not that free in a sense in the talk. So I was wondering what's your thoughts about that? Thanks.
The first question, I'm not sure I fully understood it. You're wanting to simulate a school environment.
Exactly.
But then, I mean, I don't understand how you could simulate it because you don't know what's coming next in human society. So how could you simulate a human society?
Well, but you simulate a lot of it. I mean, you can have random number generator and use randomness, and just like in a game, you can have a procedural generation of new stuff, and you may have, you know, a lot of human-like experiences, and then you can.
No, but that's not how humans learn. Humans don't learn from random number generators. They learn by being immersed in the society and learning fluency from the society. Well, what is there to simulate? It's the society. It's like saying, can we simulate the weather? Well, does it count as simulating if it's not raining? You know? So it's the same. I mean, my children, I remember when my children reached a certain age, they suddenly said to one of my sons said to me, "Did you see that match, Dad? That was a wicked goal." And I had no idea what I was talking about. What's a wicked goal? But it was the expression that was used among teenage kids at that time for a very good goal. Yeah. And I picked it up eventually. But you can't simulate that because it's the actual thing that's happening in society that you have to learn from if you're going to simulate human intelligence. So I think the simulation angle of things doesn't belong. Now the free will angle of things, Now, what was I going to say about that? Sorry, I did have an answer to that. That's quite a difficult one. Do I believe in free will? Well, obviously, I don't believe in free will to the following extent. What languages do you speak?
I speak English and Spanish mostly.
Okay. Say me a sentence in Chinese.
Oh, that I wouldn't be able to do.
Well, you haven't got free will then. Problem solved.
Well, I don't believe in free will, so that's not a problem.
Okay. That's the answer to the question.
Great. Thanks.
Hey.
Wang.
We have a short follow-up from Christian Wenzel.
Okay.
I think we should treat Harry to that. Okay. But can you not, he writes in the chat, but can you not simulate the environment? Think of the brain in the vat.
The brain in the vat. But I thought there are all kinds of problems with the brain in the vat. For example, how does the brain in the vat is somebody's brain that's stuck in a vat and then is connected to the world through wires and things like that feed in all the information from the senses which are outside of the vat, right? But the senses are outside of the vat, the eyes and the hands and the skin and so on and so forth. And there's just a connection to the brain in the vat. But the trouble is, how does the brain in the vat get drunk? I think there are all kinds of problems like that with the very notion of the brain in the vat.
Okay, we have another question by Fred Grimmel.
Wait. There was Sia Wang. Still wait in the.
Oh, she's gone. She's
gone.
Yeah, okay. She's not in my list anymore, but she's there. Okay.
But she's there. Yes.
Oh, hi. Hi, Peter Collins. Yeah, like when you mentioned like, oh, can someone speak Chinese and Japanese? Yeah, me. but my English is not well because I live in Scotland. Is that like immersed? Because I immersed in the UK, but currently like I'm in Birmingham, so like I hope to maybe have like more profound collaborations with you. And I am very interested in your like third definition of AI, namely like AI as a science which attempts to understand humans by simulation. Personally, I have like two questions. The first one is like, well, in practical, like maybe like, like the journalism, they always say like, if AI like AlphaGo, like, they beat the human player or something, and the journalism will say like, oh, like AI kind of we are not unique because AI is like learns the creativity as like as human. And my question is like, do you think through the, well, let's say if simulating it's can be achieved, do you think it's like it will make us in a kind of endless redefinition kind of way about what it means to be human? And secondly, well, since you mentioned the Turing test and other stuff, I wonder like if this kind of the test have the like the problems of anthropomorphism, like we like namely like we think they like your question, like why people they just claim what AI can't do, but they claim what AI can do when AI can't. So maybe like because of the anthropomorphism. That's my two questions. Yeah.
I do think there's I'll start with the second one. I do think there's an awful lot of anthropomorphism around in this philosophical and sociological area. For example, you can read over and over and over again that very simple things are social creatures because they affect society. But that's not what a social creature is. A social creature isn't something that affects society. A social creature is something that can interact with society in the same way that a human interacts with it. So, I mean, you know, one of the famous sources for all this is, shouldn't get onto this without preparing myself beforehand. Merleau-Ponty, this famous story of the blind man and his stick. And he says, look, the blind man uses the stick and eventually the stick becomes part of the blind man, okay? But he never asked the question, does the blind man become part of the stick? And that's what you need if there's going to be this kind of symmetry that would make the equivalent of making the stick into a social creature. Yeah. And so it's easy to pretend that a machine is a social creature if it's affecting your social life. So for instance, undoubtedly the airline booking system that I booked on once to fly somewhere was part of my social life, because when I got to the airport, they told me I had to buy a new ticket. And I said, why? And they said, well, because the name on your passport is Harold Collins and the name on the ticket is Harry Collins. So that had become part of my social life because I couldn't fly any longer. But you wouldn't say it was an intelligent creature, would you? You wouldn't say it was a social creature, because any social creature doing booking would understand enough about society to know that the Harold Collins on the passport was the Harry Collins on my books. And it wouldn't have been a problem. So I don't know if that answers your question, but that's kind of where I've gone with it. What was the first part of the question?
Well, it's it doesn't matter. I just feel like, you know, by claiming AI can help us understand what it means to be human, are we going to an endless way kind of to reduce like the human traits, or like, you know, we are forced to redefine what it means to be human, because we think like maybe what AI can achieve it's not part of the human uniqueness anymore. Yeah,
well, that's why it's very important to really consider what the human is first before you decide. The subtitle of my book is Against the Surrender of Humanity to Computers. You know, there's a lot of fuss about the so-called singularity, when we'll all become slaves to extremely powerful computers, extremely clever computers. That's not the danger. The danger is that we all become slaves to extremely stupid computers, because we don't know how to recognize their stupidity.
Yeah, I definitely have same experience as you, as like the booking flight ticket. It's like the recent case of the vaccine stuff. I was refused to a vaccine because they say you live in Scotland. We don't have you in our database in the NHS. That's ridiculous, you know. But yeah. But I think.
Okay, Sija.
Thank you. See you.
Okay, thank you. So the next on our list is Christian Götter, who will be allowed to speak and be shown.
Need to unmute.
Thank you very much. I was wondering, in a question that goes back to what Linda Janssen asked earlier, if you want to change the behavior of a group like AI scientists, whether in a model where society is consisting of a group full of group constraints, so to say, whether the change could come from within the group of AI scientists, or whether it would have to come from without, because if someone wanted to start it from within, this new behavior would be corrected by other members of the group as kind of deviance from the norm, so to say. So could change come from within, or would it have to come from without, from other group relations?
Well, I think it might come from either from without or from within. I mean, if anybody's listening to me and they took any notice of me, it would be coming from without. But I don't see why people shouldn't think about this themselves. I mean, groups do change. They change gradually. So in gravitational waves, the group gravitational wave detectors started off using one kind of detector and over the years switched to another kind of detector. I watched the change. So things like this could change from inside or from outside. I wouldn't say there's a rule.
Thank you very much.
Okay, and then we have Fred Grinnell wants to ask a question. Just reminded us of that, but we have not forgotten you, Fred. Please, go ahead.
Hey there.
Hi.
Harry, thank you for your talk. And I have to say that I'm sitting here in Dallas, Texas. If it wasn't for Zoom, I probably would not have had the opportunity to come and hear you speak. So while Zoom has its disadvantages, it really, for many of us, makes it possible to participate in things all over the world. So I appreciate that. So Harry, a few years ago, I reviewed your book, Are We All Scientific Experts Now? And sort of began thinking about your ideas of three phases of